All right, welcome back. Today we are diving deep into the very heart of how programs think. We're going to break down the core logic that lets software make decisions, react to what you do, and, well, be useful at all. So let's pull back the curtain and see exactly how it all works.
I mean, it kind of seems like magic, doesn't it? You type in your password, you hit enter, and boom, it just knows if you're the right person. But it's not magic. Under the hood, the code is just asking a really simple question. Hey, does the text they just typed match the text I have on file? Answering that one question is what this is all about.
And these three little keywords are how it all happens in Python: if, elif, and else. The best way to think about them is as a toolkit for asking questions. If asks that first most important question. Elif, which, by the way, is just a mashup of else if, asks a follow-up question. And else, well, that's your catch-all, your plan B for when none of the other conditions are met.
So let's kick things off with the most fundamental decision a program can make. It's just a simple fork in the road, and all you need are if and else. Let's go back to that password example and break it down. First, the program gets the password from the user. Then comes the moment of truth. It checks if that input is exactly secret 123. If it is, one thing happens. If it's anything else, a typo, the wrong password, anything, something else happens. Simple as that.
And this is what that logic looks like as actual Python code. Now here's a super important detail to notice on this slide. See that double equal sign? In Python, a single equal sign is for assigning a value, like make this variable equal to that. But a double equal sign is for asking a question. Hey, are these two things equal? That, plus the colon and the indentation, tells Python exactly what to do based on the answer.
All right, time for a quick challenge. Take a look at this code. Don't worry too much about that double slash. Just focus on the main question inside the if statement. Is the result of marks minus cutoff greater than or equal to 0? Based on that, what's this code going to print? Feel free to pause and think it through.
And the answer is fail. So why is that? Well, for the code inside an if block to run, the condition has to be true. In our case, 55 minus 60 is -5, and -5 is definitely not greater than or equal to 0. So, because the if condition is false, Python just skips it, jumps right down to the else block, and prints fail.
But, life isn't always a simple yes or no question. Sometimes you've got way more than just two possible outcomes. A simple pass-fail just won't cut it. And that's where our second tool, elif, comes into play, letting us build a whole chain of decisions.
Just think about how you'd grade a test. It's not just pass or fail, right? There are different brackets for an A, a B, a C, and so on. A simple if-else setup just can't handle that level of detail. We need a way to check multiple conditions, one after the other.
And this is how you build that logic in Python. We start with if for that top-tier grade. Then we use a chain of elif statements to check the next brackets one by one. Each elif only gets checked if the one above it was false. And finally, that else at the bottom acts as our safety net, catching any score that didn't clear any of the other hurdles.
Okay, so we've got this chain of questions now. But how does Python actually decide which path to take? This is a huge deal because the order is everything, and understanding these rules is the key to avoiding some really common bugs.
So here's the most important thing to remember. Python reads your code from top to bottom just like we do. It checks the if, then the first elif, then the next one. And the very moment it finds a condition that's true, it runs that code block and, this is the critical part, it completely skips the rest of the entire chain. It doesn't even look at them.
Let's look at a super clear example. Here, the variable x is 10. Python starts at the top. It asks, is x greater than 0? Well, yes, 10 is greater than 0, so it immediately prints positive.
Now watch what happens next. Even though the elif condition, is x greater than 5, is also true, Python doesn't care. It never even checks it. Why? Because it already found a true condition, ran that code, and then jumped straight to the end of the entire if-elif-else block. Remember, only one block in the whole chain will ever run.
Okay, now for a pretty cool Python shortcut. Python has this concept called truthiness. It basically means you don't always have to write out a full comparison like equals equals or greater. Some things are just naturally considered true. For example, a non-empty string like Alice is truthy, but empty things like an empty string are falsy. This means you can just write if name to quickly check if a user actually typed in anything. It's a nice little time saver.
All right, we've covered the individual tools, we know the rules of the road. Now let's put it all together and solve a classic logic puzzle that really shows off why getting the order of your checks right is so important. So the rules for figuring out a leap year are surprisingly tricky. You've got your main rule and then a couple of exceptions that override it. Generally, a year is a leap year if it's divisible by 4, unless it's also divisible by 100. Except if it's also divisible by 400, then it's a leap year again. See? It's a perfect job for an if-else-else chain.
And here is the solution in Python. Now, that little % sign, that's the modulo operator. Don't let it scare you. All it does is give you the remainder after a division. So when we say year %400 equals 0, we're just asking, is the year perfectly divisible by 400 with no remainder? Notice how the structure of our code perfectly mirrors the logic of the rules we just went over.
The order here is everything. It's not random, it's the key to the whole puzzle. We have to check for the most specific exception first, the divisible by 400 rule. If that's not true, then we check for the other exception, the divisible by 100 rule. And only if both of those special cases don't apply do we fall back to the main general rule about being divisible by 4. If you get that order wrong, the whole thing falls apart.
So as you can see, if, elif, and else aren't just lines of code. They are the fundamental building blocks of intelligence in your programs. Every time an app responds to you or a game reacts to a choice you make, this is the kind of logic that's chugging away behind the scenes. Now that you have the toolkit, what kind of decisions are you going to teach your programs to make? Thanks for joining this explanation.